Hello everybody, thank you for coming to my presentation. Today I'm going to be talking about automated bug hunting with Semgrep. It's a 45-minute presentation. I'll try to end a little bit early so we can ask some questions. But by the way, these slides are available online, at least the first half. Planning to get some more out online as well. And I'm going to have a link in the description at the end where it's credited, and you'll be able to see where those slides are. So let's dive into it. My name is Ethan Morchi. I'm a hardware/software penetration tester here at Somerset Recon. We have the Lockpicking Village, and we're sponsoring the conference as well. Please check it out. We have a lot of really cool items, locks, safe cracking, and all those very interesting things. A little bit about me. I love techno music. I love sci-fi books, movies, TV shows, you name it, and lockpicking as well as a personal hobby of mine. All right, so a little bit of a table of contents. Semgrep I'm going to be using today is a static analysis tool, and I'll give a brief introduction to that. I'm then going to talk about the rules of Semgrep as well as different types of patterns and things that might be useful when finding that, as well as the autofix vulnerabilities as well that can be fixed using Semgrep, the best practices, and lastly I'm going to end it with two examples, a WordPress demonstration and an open source code demonstration where I'm going to be demonstrating a tool that I created. And hopefully we'll be able to find some bugs. So let's dive right into it. Semgrep is a static analysis tool that leverages OCaml as a programming language to, as it says in the slogan, code scan at ludicrous speed. It's open source. The pro version is a little bit more proprietary, but you're able to download that and run it yourself as well. So diving into the word Semgrep and what it means, according to their GitHub documentation, Semgrep is a portmanteau of both semantic and grep. For those of you who may not be familiar, grep is a Linux utility tool that allows you to scan files and search for like blobs of text. If you give it a parameter, I might have it here. Yes, I do. So if we were to take a look at an example of grep, say this is a C source code, it takes a look at a function called main and then defines certain variables. If you were to say, for instance, look for the number 2 using grep, then it will highlight around the letter 2, or the number 2 on line 3. If, however, you were to use Semgrep, it would not only identify the actual integer 2, but because x is defined as 1 and int z is defined as x plus 1, it is able to tell that 2 is in fact a number. It uses what's known as like semantic. It looks at the syntax of the code. So it's not just blobs of text that it searches through. It actually understands what variables are, what functions are for a plethora of languages, and is able to determine what is technically known as a variable, what can be a string, multiple different types as well. And this will be useful, as you'll see, in bug hunting automation. So this is another example where the language is in Python, where the test is the function. In this case, Semgrep recognizes line 4 as being number 2, but line 3 has 22. It's 2 2s. And grep would actually highlight the 2 individual 2s, but Semgrep is smart and it understands that that number is 22 and not 2. And here's one more bigger example using the Go language, where it's able to understand larger arithmetic operations such as addition, multiplication, subtraction, division, and modulus as well. There we go. So these are currently the supported languages on Semgrep. As you can see, I think it's over 30, perhaps over 40 with some of the proprietary ones. Almost everything all the code I've ever seen is on here. So Semgrep is a very versatile tool that can be used for various purposes. Okay, let's dive into the example code here. So we're going to be creating a rule pattern with Semgrep and then eventually expanding on that in order to start hunting vulnerabilities. So let's take a look at the example code. Here is a C code where it takes a look at a static hello string, and then it prints that string using printf. If you were to use grep and run printf of x, it would highlight that. Same thing if you had printf of x, you could highlight that with grep. If, however, you were to use regex, which is a way to identify more strings using special symbols. For instance, the dot asterisk means anything, like any type of text inside those parentheses. And in this case, it would highlight both printf(x) and printf(y) because, again, anything inside those printf parentheses will be defined. Semgrep, on the other hand, has something a little bit different with the format. This is the rule. It looks a little bit long, but it's really not. It's just the rules. You have the ID where you say the name of the rule. You provided a pattern, a message, say the language, and then lastly severity to mention what the type of bug is like. And that's most of what you would need to know there. In this case, I'm defining the pattern as printf of x, which is the same thing as grep printf of x, but in this case, you'll see it start to develop into more and more complicated rules that we can use that grep will not be able to. So there's printf of x, there's printf of y, and in this case, you can use something called pattern either, which means either or, so printf of x or printf of y. And there's also 3 dots and ellipses, which is very similar to the dot asterisk in regex, but the difference between the two is because Semgrep uses this type of semantic analysis of the code, the ellipses actually represents the code inside, not just whatever text blob is in there. It actually verifies it as being variables. And here's another example here where the patterns means it requires both those patterns of printf with the dot dot dot, and in this case it has a pattern not, which means, as you'll see, printf dot 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 will highlight both lines 4 and 5 because, as we said before, that gets highlighted, but pattern not will cancel out printf of y, only leaving printf of x. It's very similar to printf dot 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 and not printf of y if we're using the mathematical notation. Yeah. Oh, and I also just wanted to say, this can be expanded using other things as we'll mention here, but this alone is a demonstrated impact in code analysis that is much more than just analyzing blobs of text using grep. And onward. All right, so now comes one of probably the most useful functions I've ever used in Semgrep, which are the meta variables. So because Semgrep as a whole is similar to a programming, like it analyzes programming code, the rules that we're creating is in a YAML format. It's this type of file structure with the rules, and we're able to use code inside of that rule to aid with our analysis. So in this case, we have a gets function inside of C code. Gets, for those of you who may not know or are new to the security realm, gets is a vulnerable function in C. It asks for any arbitrary input from the user, and then it stores that in a buffer. And in the case of user, it's 32 bytes, and if you give it more than 32 bytes, which is like spam the letter A like 64 times, it will overflow that buffer and allow you to do some type of memory corruption, which is a vulnerability in of itself. So in this case with the Semgrep rule, you're able to identify what the pattern gets. But instead of doing the dot 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 or the dot asterisk in grep, you can do gets with something called a $sign, like the $sign with the meta variable inside. So in this case, I have $buff, and that assigns whatever the input inside gets is to whatever code or variable it is. And in this case, if I define the message as gets writes to buff, that buff is stored the user variable name, and then in that message of the output on Semgrep defines gets writes to user. So it's very useful to analyze from a message standpoint, provide an input, and then get the name of, for instance, the buffer that ends up getting returned using the message. But this can have significantly more impact. For instance, there. It seems kind of complicated. I'll highlight the colors so it's a little bit easier to understand. But in this case, pattern is spanning multiple lines, hence the pipe in the beginning. And all of these meta variables are now just placeholders. Placeholders for the variables and the variable type names and everything like that. As you see, type, the $sign type, is assigned to char. The user in the orange is assigned to the $buff, and the $sign size is attached to like 32. And onward, you can see the color-coded thing there. And this would correctly identify this as just being a match, as you can see. But there lies a problem, because fgets in of itself is not vulnerable. If, for instance, 64 was provided to 32, sorry, let me rewind. If fgets in the second argument says 64 bytes, then that allows the user to provide 64 bytes. And if user is only 32 bytes, you're able to overflow that buffer. But if, for instance, it was 12 bytes or 24 bytes or something less than 32, that's not vulnerable. And it can be pretty difficult, you can't even use grep in order to tell, using fgets, what that buffer variable size is. So luckily we have Semgrep, and we're able to use something called metavariable comparisons. And that's just comparing two arithmetic metavariables together. So in this case, $size is defined as 32, and $max is defined as 64. We saw that previously in the pattern. And with this metavariable comparison line there, and we compare $max is greater than $size, we're able to only highlight rules where the pattern actually matches. So in the case of 64 greater than 32, that's vulnerable. And in the case where any fgets input has a buffer size that's larger than the buffer that goes into it, that's vulnerable. And we're able to, using Semgrep, clearly define, limit the false positives, and have clearly defined rules of, yes, fgets is vulnerable only in this context, and here's a rule where we can provide it. So yes, you say here, 64 is greater than 32, that's vulnerable. If, however, 12 is less than 32, it would not recognize that as a pattern. All right, so Semgrep Pro features, there's a little bit more of what the world of Semgrep is. There's a lot more analysis that can be done besides just using metavariables, besides using pattern recognition. There's something called cross-file analysis, where that's kind of in the name, there's multiple files that can be used in this process. If you have a C header and multiple C sources, or a Python library that you're importing and also running that, Semgrep, using the Pro feature, is able to propagate throughout all of that, build out a tree, and recognize which variables are being used where. And that is, of course, very useful when there are multiple files that that interact with each other. And you may not always have just one Python file that you're going to scan. In this case, you can have multiple hundreds, thousands of files that all work together, that all use and change in very different variables that Semgrep is able to understand using the Pro feature. There's also intraprocedural analysis, which is personally a favorite of mine with Semgrep, because it allows you to analyze variables that may change their names throughout functions. Because as we saw there, we're able to define that one variable with buffer. But if that ends up getting used in another function somewhere or returned somewhere else, you need something like Semgrep in order to propagate and use intraprocedural analysis to analyze where those sources and sinks come from. And lastly, the other Pro feature is the enterprise languages, such as Salesforce Apex, where those kind of enterprise languages may or may not be commonly used depending on what your line of work is, but for those enterprise languages, Semgrep does support that in the Pro feature. And now we get to talk about taint analysis. So we have an example here with Python code. As I could just walk through it really quickly, it imports the OS package in the receive function from lines 3 to 6. It gets user input using the input function and then returns that input. Very simple function there. And lastly, in the test function, the data variable ends up getting that user input and then directly executes it using os.system on the computer. This is recognized as a vulnerable function because it's taking arbitrary user input and then just executing it directly as if this was Linux, for instance, just regular Linux command. So you can type in input echo hi, and then it would run that, or cat etc password, and find certain password files, and it's known as a vulnerable function. And in this case, we broke it out in 2 different functions because we're trying to demonstrate the use of intraprocedural analysis to identify the vulnerabilities, even if they have different names. So here's an example of a Semgrep rule. In this case, I called it command injection because that's what the vulnerability class is called. This pattern here is, again, multi-line, hence the pipe, and it defines the variable, the metavariable, equaling the input with the parentheses, and then we have a ... which means any line spanning. You could have multiple lines spanning between the two, and then eventually OS system with the variable. This rule does not use intraprocedural analysis. It used the vulnerabilities that we saw before, the rules that we saw before, but this does not actually catch the vulnerability. And the reason why is because these 2 metavariables that we're using have completely different names. In this case, the variable, the $var, first defined in the rule, is user input, whereas the $var recognized in the second is data. And because just using this basic search algorithm, user input does not equal data, it just is not recognized as a match. But this is a match, and we need to have a rule defined where we're able to explain, yes, using this type of Semgrep rule, we can find this match. And that's where interprocedural analysis comes in. This has a different mode, as you can see, line 3 of the YAML file. The mode is defined as taint. It uses different pattern sources and pattern sinks. So a source is where maybe the user input comes in, and the sink is where the code ends up getting like defined to execute. So in this case, we want the source of like the user input to be input. That's in the name. But the pattern sink we want to be os.system, because that's where the data gets executed. And what this program will do, or the Semgrep interprocedural analysis rule, it will take the input and travel from the source to the sink and attempt to identify where those patterns, where the code ends up getting defined, where they meet together. This is kind of a crude example. Oh, no. Let me show. So like, for instance, these are the arrows that end up following the source directly to the function def_receive, and then the sink from the data to the receive function back to the function. And through that kind of zigzag pattern, it's able to identify, okay, the source is input and the sink is os.system. Great, those connect, vulnerable, there's the pattern, there's the match. And as just a personal, interesting example, this os.system, let me put it there. Yeah, this os.system could be something else. You could import os.system as execute me, for instance. And execute me would be a vulnerable thing, it's just changing the name. But because Semgrep's smart, it's able to analyze execute me, recognize it as being os.system, and still find that taint analysis rule. Great, okay, we're looking good on time. So now we're going to talk briefly about autofix and the types of rules that you can do there that Semgrep can do with the exact same thing that we just talked about in order to fix the vulnerabilities as they identify. So we're going to go back to the vulnerable code here. Vulnerable code, user, gets user, the gets function is vulnerable, arbitrary input, great. Now we have an autofix rule to fix that. And in this way, we first have to identify it. As we identified before, the pattern is gets with the buffer in it. Once we find the gets with the buffer in it, and that's identified as a match, then we can implement our fix. And we see in the autofix rule, it says fix, and then we have our fix. And what that essentially does is replace that gets function with whatever function we end up giving it. In this case, we give it fgets because fgets is more secure. And we know fgets is more secure given the right conditions. In this case, we use the size of, and due to the meta variable being defined in that pattern, and $buff is known as user, then we're able to end up fixing it and replacing it as fgets. And I have the code, like the line of code that you'd input at the bottom in order to identify the rule. This, just running the rule basically by itself, gets is recognized, it's a match. But in order to fix it, you do --autofix, and as you see, the gets changed, but it still hung on to the variable user because the user was defined as that meta variable. Let's see here, $buff was assigned as user. And then again, as you do the autofix, gets changes into fgets. All right. So I'm briefly, for about 2 slides, I believe, going to talk about the rule tips. These are going to be very useful. And again, these slides are online. I'll reference them in case I move a little bit too quickly through some of these interesting points. But what I like to consider the 3 C's is good for rule writing and identifying which rules are possibly more important than others. If you have a file built out or a directory with multiple files, with multiple rules, and you have Semgrep rules hammering away at a piece of code, you want to be able to differentiate between all of them and determine how likely certain things are a match, how likely things could be a false positive, how dangerous it could be. And in this case, I like alliteration, so I use the 3 C's. The criticality is how dangerous. As we know, with vulnerabilities, it could be critical, high, medium, or low. The confidence of the vulnerability as well, because the case of the true positivity, for instance, if we just ran that fgets rule, we just searched for fgets with no meta variables, then the odds of that potentially being vulnerable go way down because you're not doing any other type of analysis. You're just looking for fgets. So the true positivity rate could be high, medium, or low. And lastly, the coverage is how well it's covered. If you run gets and you search for gets, you're finding all the functions that say gets. That's a very high coverage. But if, however, you start using other functions, you're trying to identify other things, whatever it may be, and I will discuss some of these other live examples later on, that scenario is in fact covered, and you can have high, medium, or low, depending on that type of coverage. Cool. So Semgrep is a command line tool. I just run it directly on my Linux terminal shell, and there are many flags that can be used that can aid in analysis. And I've been using Semgrep for quite a long time, and the different arguments that provide here is kind of a comprehensive list of what I found to be the most useful. There would be a lot of times where the rule might not have run correctly, or the file might have been skipped for some reason, and I always reference this command tip guide because it allows you to understand, okay, like maybe that's why it didn't work. For instance, the timeout key, by default, if after 5 seconds your rule doesn't work, it stops. So if you set the timeout to 0, it'll keep running until the rule finishes, which is great on 4 million lines of whatever type of code you might run, where it will take a significantly longer time. And more to that point, the maximum file size is 1 megabyte, but if you set max target bytes to 0, you could have, I don't know, however long, a gigabyte's worth of code in one file, and Semgrep will be able to run that. Meanwhile, you can also output the findings to multiple different files, text, JSON, Vim. There is a serif file output, which I personally don't like reading visibly, but if you import that into Codium, VS Code has a special plugin for rules, like serif file rules, where if you just drag and drop, it'll highlight on your actual code where each of those rules are, along with helpful tips. And one time I was able to find, for instance, like memory leak vulnerabilities, let's just say. And if you have a rule for, say, memory leak vulnerabilities, and you were to like have it drop it on Codium, and it gives you, let's say, 50 different outputs, then you're able to click on it and look at all 50 of those outputs, and with the left and right arrow, determine whether or not it's vulnerable or not vulnerable. So this greatly reduced the amount of time that I'd have to research in the code. I could just go to the VS Codium, go to the right side, and then see, okay, is this vulnerable? Yes. Is this vulnerable? No. And in a couple minutes, I was able to determine whether or not 50 of those rules were actually positive or fake. Let's see, pro, of course, --pro is very important if you want to run the pro command. It will not run it by default, and it does have a subscription as well, a paid subscription to purchase the pro. And I think lastly, -j is the amount of cores that it runs. Definitely speeds up the amount of time when you run multiple jobs in parallel. Sometimes it might only run with one, but this is an 8-core computer. If I run with 8 cores, it makes it significantly faster to build out all of that code. And, oh yes, lastly, -c is the configuration files. You can have multiple rules. You can specify a directory that's all locally. And there is a website, semgrep.dev/explore, that has, at least up to date now, that has a list of publicly community created, curated rules that are specific to whatever you might want. Some of these rules are created for security. Some of these rules are created for like PEP 8 standard specifications or code quality. If you're using too many characters in one line of code, it might give you a warning. Or if there's any other type of correctness, code quality, those types of rules have been created for that purpose as well. And if you visit that website, you can find multiple different languages for multiple different things. And I'll explain that in a live demonstration in just a bit. Oh, speak of the devil, demo time. In this case, I'm going to be discussing WordPress. So a little bit ago, I think it was August 2024, a person found a bunch of critical vulnerabilities inside of WordPress plugins. WordPress is a website service, and they have multiple plugins that you can add to your own website that is code created by the community or other people. And once that plugin is in your website, it is in your website. It's part of your code base. And what this person did was download every single WordPress plugin, which you can do freely online. It has a public API. And he ran static analysis tools on it to determine just a very simple one, very common online code rule. Hey, let's see if this thing's vulnerable. And sure enough, he found multiple critical vulnerabilities off the bat just by running that. And that's his website as well, if you want to see that. But, oh, yes. But in this case, I have a demonstration. So I did something pretty similar. In this case, I have WordPress, and I want to demonstrate, let's see, a couple rules and the types of rules that are currently online, and then some rules that I've created for analyzing some of these plugins. So WordPress runs with PHP code. It's great, and you can tell whether or not some things are vulnerable with public vulnerabilities. So for instance, there is a rule created online that you can access on the Semgrep website that checks whether or not, all of this is like metadata messages, but the big thing in this rule determines, can you all see this okay? Yeah, okay. You can determine whether or not it's running something called unserialize. Unserialize is a function in PHP that can be vulnerable. It has a lot of vulnerabilities for something called deserialization attacks. So serialization is when you have some type of code that may be like user inputted or some type of text that ends up getting converted to some other form and serialized, whether like for instance, JSON is an example where it takes user provided words and text and converts it into some type of ability to package it in like some string or binary. Then deserialization is the opposite of that. It takes that binary or that string and then converts it back into the text that was given. And in some cases, in some deserialization functions, like in unserialize, if you're giving input that is vulnerable, for instance, like just arbitrary PHP code in its string, when it tries to unserialize that, it'll recognize that as valid code and then just directly run it on the system. And that's an extreme vulnerability because sometimes it can lead to remote code execution. If you just give it arbitrary code to deserialize and it deserializes whatever you want it to be, that's a vulnerability. So this default rule on Semgrep and contributed says unserialize ... which means anything inside that unserialized function is vulnerable. It does have a pattern not, and that pattern not has 2 quotation marks around it, which means if it's just a static string, it doesn't count that as a match, which you can see it's like, okay, if you're not providing that code, that may not be vulnerable, that's okay. And that's the rule that was created to run. And I can just run it right now. By the way, I do want to say, there is a plugin here called Ew Image Optimizer. Currently it has over 1 million downloads. This is an older version of the Ew Image Optimizer. This plugin had vulnerabilities that ended up getting patched. So this is not currently exploitable using this particular way that I'm about to demonstrate. But I can demonstrate here. Semgrep-C specifies the configuration file, which is unserialized use. And then I'm going to say the folder, which is Ew Image Optimizer. And if I run that, you'll see the CLI, it runs, and immediately, boom, done, figured out the rule. And it said ran 1 rule on 11 files, 8 findings. And if you see here, off the bat, it unserializes $post ew attachments. And PHP, when creating websites, you're able to provide information in post requests. And if you provide a post request with a key value being ew attachments, this essentially means whatever information you provide just directly gets called in unserialized. That's a deserialization attack. That Semgrep rule found it, and it's great. It's fantastic. It also found many other findings too that may or may not be vulnerable, like image1 or $attachment and all of those things. And I looked at that and I thought it's very interesting, it's great, but if you were to run this on scale, is there a way to have more true positivity, only have things that are specific to one that we know are vulnerable, like $post, and specify exactly what kind of vulnerabilities we want? And there is an example here. Oh, before I demonstrate mine, there is another rule online as well for deserialization that does look a little bit more complicated right here. It uses taint analysis, which we discussed before. It looks for anything inside $get, anything inside $files, and anything in $post, which all of this is user, or most of this is user provided, where if we provide any get data or any post data, that is the source right there. The pattern sync is extract. Extract is another function that is a deserialization thing. It's just like unserialized, it does something a little bit different, but if you also provided arbitrary code, it will execute that, and that's a deserialization attack. There's one more thing called pattern sanitizers, which is kind of a negation, where if during that code flow, there is something there that sanitizes that input, then it does not count that as a pattern. So in this case, extract with extra skip, what this variable means, ends up mitigating some of that risk, so they don't count that as a pattern match. All of this to say, I'll probably just move in. My rule here is a little bit more complicated, has slightly more information, but it still uses taint analysis, still uses the pattern sources, only this time, instead of get and post, it uses all of the other things, like server, HTTP refers, or anything that you might be able to control, user agents, path translated, query strings, authentication types. All this stuff are potential avenues of exploitation that were not listed in the public rules. And the pattern syncs combine both extract and unserialize. The pattern sanitizers include far more sanitization methods. So sanitize key or escape HTML, all of this sanitization that I would otherwise be able to exploit cancels out the ability, at least in these non-novel ways, to attack the system. So if I were able to run Semgrep again with my rule instead on AO image optimizer, it instead only highlights those 2 findings rather than all 8 of them. And this is great because this rule in of itself is fine for this AO image optimizer where it's only 11 files of PHP. But here I have over 3,000 plugins of WordPress that I downloaded in a folder that using Semgrep, I'm able to scan. And if 6 out of 8 of these rules that I used with the previous rule are not vulnerable, that can take a lot of time with analysis. My rule that I created is more curtailed towards bug hunting, being able to find these with some higher true positivity rate and higher coverage. And I created just a quick script to demonstrate that. If I were to show my rule and I were to run the script, then it would go through all these plugins and start running and searching for all of it. And I'm going to stop that before it might show a match because I have not set up public disclosure yet. And that kind of no matching, all of it's stored in a file where I can view the results and the findings. And this just demonstrates how, with your own rule that you create, you're able to do something quite similar where you can find vulnerabilities online that utilize this type of information. Cool. I'm on time. Great. All right, let's see if we can knock out this other one. One other demonstration. So we use WordPress vulnerabilities and WordPress plugins. That uses PHP code, and that's strictly defined to WordPress. But GitHub's open source. And GitHub has over 200 million repos of source code information. There has to be a way to get to that and run static analysis tools. And there is something called grep.app. It is a website, grep.app, that would code search with, it says code search made fast. It already has searching for all of this code, where if you provide just a regular string, not a Semgrep pattern, but just a regular regex compatible string, it will search that code. And you can give it, for instance, like a query or a language, and it will filter out based on that information. And as we see, filtered code. You can also specify, in this example, I used eval. So eval is a Python executable. It's also like a deserialization attack, but it's command injection. If you were to provide anything inside eval, that is a vulnerability. So this query looks for eval in all the 200 plus million repositories. It filters the language based on Python, so we can be really sure that we're using eval as the right function in that right language. And lastly, we're using regex because we're using regex, and we're matching the case because we don't want any capital evals. And with that, might be difficult to see, we'll see. This grep.app will show many results. For instance, there's this one code base here that says eval and has information inside. but for some of you who might be able to read that, it doesn't show with 100% accuracy whether or not these things are actually exploitable. All it does is filter down to 973 repositories, and it doesn't show any other additional information that might aid in our analysis. But because the code base is so large, we want to have something static that we can use and scan. And that's where Semgrep comes in. Semgrep is able to take a look at that code and find the vulnerabilities. But grep.app and Semgrep don't work together. They're not integrated together. This is an example, by the way, of a rule to find eval. It uses the same thing that we found before with the input as the source, where if we provide an input and it goes directly into eval, that's a vulnerability. So that is, for instance, a rule that can work in this kind of flow and find the vulnerability. But this seems a little bit complicated, and it uses grep.app, it uses Semgrep to kind of put together. So in comes this little app. It's a piece of software that I created called Quacc++. It's like DuckDuckGo, but for vulnerabilities. And it integrates both grep.app and Semgrep together to find that information. So I can move on to this one. So this is a predefined thing because it uses the internet. I didn't know what the internet would be like. So this will show a man-in-the-middle vulnerability scan. I'll walk through it as we do it. So what this will do is run the script that I created for Quacc++ in interactive mode. It'll enter the path of the Semgrep rule that I created, which is, man-in-the-middle.yaml. And by the way, I can output man-in-the-middle.yaml. And this shows the pattern that I created. It's fairly inclusive of multiple things, but the one that we're going to focus on in this rule is looking for the wget command. Wget would download a file, and it checks here whether or not it uses something called no check certificate. If no check certificate is highlighted and used in wget, then it downloads stuff over HTTP. Even if it's HTTPS, it downloads over HTTP, it doesn't verify the certificate, and it's vulnerable in the sense that if someone had the ability to do man-in-the-middle, they'll be able to inject whatever they want in the website, and that can lead to potentially other vulnerabilities. During a firmware update process, if they use no check certificate, then the secure connection that they'd be able to make with HTTPS is null and void, and you'll be able to potentially man-in-the-middle, inject your own firmware, do all sorts of nefarious things, and we don't want that. So this will help identify in public code bases what's vulnerable. So there's a little duck. And the search term for the vulnerability is using regex. This is wget with the dot asterisk and no check certificate. And the search options here can be case sensitive or regex. In this case, I'm going to highlight both because we like both. Here, we're able to specify the language as well. We only want, let's say, for instance, to look at shell commands, only bash commands that use wget. We're not looking at C or Markdown or Python or anything. We're only looking at shell. And in this case, it's going to start searching the internet. It says 964 results found. I'm not going to show the example. And when I launch the analysis, it's going to start downloading the repositories. And what this does is, again, interfaces with grep.app. It finds the vulnerable or the potentially vulnerable code bases online, the repositories. It'll download the repositories and attempt to find the analysis. And for instance, here it downloaded the analysis and 13 findings found. And those are 13 findings that Semgrep, with that rule, was able to highlight. And as we continue on down the list, let's see if I can pause it well. Yeah, here's another example in another repository where 4 findings were found. And this is all stored in a way that's easy to read in another file location. All of this to say, sometimes you're going to have findings, you're going to have repositories that don't show the findings. Sometimes you have repositories that do. But grep.app is great to have all those 200+ million repositories and filter it in a way that's easy to understand. And then Semgrep can take over and start analyzing something that maybe only one computer can do, but it's pretty powerful with that. I could let it run, I won't let it run anymore. But that shows and demonstrates the impact there. And I think I might have time to give one more example. Great, okay, one more example. Here is MITM2, yeah, okay. So I'm going to demonstrate a second example here. This time I'm using the non-interactive mode of the application that I created that creates the rule The rule here is insecure HTTP, no localhost. Does something very similar, but instead of using it in a shell command, it instead uses it in C. And this uses the scanf function to determine whether or not wget and noCheckCertificate is used together. And it looks like a different format, it has a different rule pertaining to that particular language. But I can specify the language, C and C++. And then I can also say, yes, case sensitive, and the input is gonna be noCheckCertificate. There, and then it'll run, don't have to do any interactivity. In this case, it was a highly specialized regex command that I used for it. It found 40 results out of the 20 million repositories. But out of those 40 results, there's potential for some of them to be vulnerable. So what it ends up doing is start scanning all the 40 repositories and does the same thing. In this case, it kind of skipped ahead because a couple of them might have taken longer to download or might have not been vulnerable. But eventually, as it continues down the chain, no findings found, as it continues down the chain, you get to like the 10th or the 11th, 13th, it will be able to show the findings. And that way, you could just analyze all 40 of them by eyesight, or you can run Semgrep, run the rule, and it will specify, okay, here's only 2 repositories out of the 40 where we actually find the vulnerability, and we can verify that it exists. And I'm going to cancel out of that. So that is the code that I created for Quacc++. I do have plans on releasing it publicly. It will take a little bit longer. It's not currently available, but we do have to do some vulnerability disclosure before it is publicized. That was the example. So thank you very much again for allowing me to give this talk here at BSides San Diego. That is my contact information. There is a blog that I have where the slides will be up, and Somerset Recon/blog does have around half of the slides up, but we plan on having more in this full-on animation up online. So thank you very much. So I do have time now to answer some questions.